Collecting data. We can divide data into two categories. A. Primary data. When an investigator collects data himself or herself with a definite plan or design in his or her mind, it is called primary data. B. Secondary data. When an investigator does not collect the data himself or herself, but it is obtained from some other sources like magazines, newspaper, TV, etc., is called secondary data. C. Organization of data. When we collect data, we need to record and organize it so that we can interpret it in a better way. Example 1. Weight of 10 students are given as below. Organize the data in tabular form and answer the following. A. What is the maximum weight? B. How many students have weight above 40 kg? C. How many have weight below 40 kg? D. Find the difference between the weight of heaviest and the lightest student. Solution. A. Maximum weight is 50 kg. B. 5 students have weight above 40 kg. C. 5 students have weight below 40 kg. D. Maximum weight is equal to 50 kg. Minimum weight is equal to 25 kg. Difference is 50 kg minus 25 kg, which is equal to 25 kg. Representative values or measures of central tendency. A single numerical value which can represent the entire data in the best possible way is called measures of central tendency or representative values. In this class, we will study 4 ways of measuring of central tendency. 1. Arithmetic mean. 2. Range. 3. Median. 4. Mode. Arithmetic mean. Mean is equal to sum of all observations by number of observations. That is, symbolically we denote arithmetic mean by x bar is equal to x1 plus x2 plus so on till plus xn by n, where x1, x2, x3 and so on till xn are the n observations in the group. Example 1. The weekly pocket money of Anita, Rohini, Roshni, Ravina and Rashi are given as rupees 120, rupees 180, rupees 90, rupees 150 and rupees 130. Find the average weekly pocket money. Solution. Average weekly pocket money is equal to rupees 120 plus 180 plus 90 plus 150 plus 130 by 5. Rupees is equal to 670 by 5, which is equal to rupees 134. Here, the pocket money of neither of the students equals the average pocket money, that is rupees 134. However, average is just a representative value of the given data. Example 2. Find the arithmetic mean of first 10 natural numbers. Is the mean, in the brackets, or arithmetic mean lie in between given observations? Solution. We know that 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 are the first 10 natural numbers. So, to find their mean, we find their sum, which is equal to sum of first 10 natural numbers, which is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, which is equal to 55. So, the mean is equal to 55 by 10, which is equal to 5.5. Remember, mean always lies between the greatest and the smallest observations. Range. The difference between the highest and the lowest observations gives us an idea of the spread of the data. The difference between the highest and the lowest observation of a group of observations is defined as its range. That is, range is equal to value of highest or largest observation minus value of smallest observation. Example 1. Organize the following marks in a class assessment in a tabular form. A. Which number is the highest? B. Which number is the lowest? C. What is the range of marks? D. Find arithmetic mean. Solution. Marks, tally marks, number of students. 1, 1, 1. 2, 2, 2. 3, 1, 1. 4, 3, 3. 5, 5, 5. 6, 4, 4. 7, 2, 2. 8, 1, 1. 9, 1, 1. 10, 0. A. Highest marks obtained is 9. B. Lowest marks obtained is 1. C. Range is equal to highest marks minus lowest marks, which is equal to 9 minus 1, which is equal to 8. D. Arithmetic mean is equal to, in the brackets, 4 plus 6 plus 7 plus 5 plus 3 plus 5 plus 4 plus 5 plus 2 plus 6 plus 2 plus 5 plus 1 plus 9 plus 6 plus 5 plus 8 plus 4 plus 6 plus 7 divided by 20, which is equal to 100 by 20, which is equal to 5. Therefore, arithmetic mean is equal to 5. Example 2. If the mean of 6, 8, 5, x, 4, 7 and 8 is 7, find x. Solution. 7 is equal to 6 plus 8 plus 5 plus x plus 4 plus 7 plus 8 by 7. 7 is equal to 38 plus x by 7. 7 into 7 is equal to 38 plus x. 49 minus 38 is equal to x. Therefore, x is equal to 11. Median. To find the median is much easier than calculating mean. To find the median of a data, we follow these steps. 1. Arrange the data in ascending or descending order. 2. If the number of observations is odd, the median is the observation in the middle. That is, if n is odd, then in the brackets n plus 1 by 2th observation is the median. 3. If the number of observations is even, the median is the mean of the two observations in the middle. That is, if n is even, then the average of n by 2th and in the brackets n by 2 plus 1th observation is median. Median is equal to 1 by 2 in the brackets n by 2th observation plus in the brackets n by 2 plus 1th observation. Example 1. In a mathematics test given by 15 students, the following marks are recorded. Find the median for the data. Solution. To find the median, we first arrange the marks in ascending order. Here, n is equal to 15, which is odd.
Hence, n plus 1 by 2th marks will be the median.
That is, 15 plus 1 by 2 is equal to 16 by 2, which is equal to 8th observation. Hence, 8th observation, that is 52, is the median of the marks obtained by 15 students. Example 2. The weight in kg of 9 members of a team are as under. Find the median of their weights. Solution. We first arrange the data in ascending order. Here, n is equal to 9, which is odd. Hence, the median is the middle observation. That is, 9 plus 1 by 2 is equal to 5th observation, because 5th observation is 56 kg. Hence, median weight is 56 kg. Example 3. The following observations have been arranged in ascending order. If the median of the data is 63, find the value of x. Solution. Here, the number of observations, n, is 10. Since n is even, so median is the
average of its n by 2th and n by 2 plus 1th observation.
Median is equal to 1 by 2 in the brackets n by 2th plus in the brackets n by 2 plus 1th, which is equal to 1 by 2 in the brackets 5th plus 6th observation. 63 is equal to 1 by 2 in the brackets x plus 2, which is equal to 1 by 2 in the brackets 2x plus 2, which is equal to 2 by 2 in the brackets x plus 1. 63 is equal to x plus 1. 63 minus 1 is equal to x. 62 is equal to x. Mode. We define mode as the observation which occurs most often or most frequently. To find mode of a data, arrange the data in tabular form and then the most frequently occurring data is termed as mode. Example 1. Height in centimeter of 25 children are given below. Solution. Height, tally marks, frequency. 160, 4, 4. 161, 1, 1. 162, 3, 3. 163, 8, 8. 164, 3, 3. 165, 4, 4. 166, 1, 1. 167, 0. 168, 1, 1. Total 25. Here, mode of the data is 163 as it occurs maximum number of times. Bar graph. Construction of bar graphs. We know that frequency of a data is the measurement of the number of times that particular event occurs. The following steps are taken for constructing bar graph. Step 1. Take a graph paper. Draw two lines perpendicular to each other, one horizontal and one vertical. Step 2. Name the horizontal line as x-axis and vertical line as y-axis. Thus, point where two axes cut each other at right angles is named as origin. Step 3. Along the horizontal axis, take the values of the variables and along the vertical axis, take the frequencies. Step 4. Along the horizontal axis, we choose the uniform width of bars and uniform gap between the bars according to the space available. Step 5. Choose a suitable scale to determine the heights of the bars. Step 6. Calculate the heights of the bars according to the scale chosen and draw the bars. Step 7. To beautify the data, shade or color the bars lightly. Example 1. The following data gives total marks out of 600 obtained by 6 children of a particular class. Represent the data on a bar graph. Solution. We will choose equal division of 100. Thus, 1 unit will represent 100 marks because the marks variation are in 100. Now, we take two perpendicular lines as two axes. X-axis students, y-axis marks out of 600. Scale 1 unit is equal to 100 marks. Example 2.
The data is given about the number of fans sold by a shop during 6 months from March to August in 2006. Draw the bar graph and then answer the question given below.
A. In which month the sale was minimum? B. In which month the sale was maximum? C. Find the total number of fans sold in March to May. D. What was the total sale during the 6 months? E. Find the ratio of minimum to maximum sale. Solution. We will draw two perpendicular axes and take months along x-axis and number of fans sold along y-axis. Take 1 unit is equal to 10 fans. We have the following bar graph. A. Minimum sale was in the month of March. B. Maximum sale was in the month of April. C. Total number of fans sold from March to May are is equal to 20 plus 50 plus 30, which is equal to 100 fans. D. Total sale of 6 months is equal to 20 plus 50 plus 30 plus 40 plus 35 plus 45, which is equal to 220 fans. E. Ratio of minimum sale to maximum sale is equal to 20:50, which is equal to 2:5. Double bar graph or composite graph. When we want to compare the same quantity between two different data, we use composite graph or double bar graph.
Two different schools give different time periods to the subjects. Subject: School A, School B. English 8, 7. Hindi 7, 8. Mathematics 10, 10. Social Studies 6, 7. Natural Science 8, 7. Represent the information given using double bar graph and answer the following questions. A. For which subject both the schools give same time period? B. Which school gives more time period for English? C. Which school gives less time period for natural science? Solution: A. For mathematics, both the schools devoted equal time period. B. School A gives more time period for English. C. School B gives less time period for natural science.